What's going on, guys? Mr. Jones here once again. Today we're going to do a video on a new task. It's a develop understanding task called 2.3 building the perfect square. Develop understanding tasks mean it's going to be new and difficult, so please allow yourself to struggle. Please allow yourself to make some mistakes, and don't just take the answers and turn it in and think that you have succeeded. You have succeeded if you make some mistakes and are able to correct those mistakes and learn from them. So with that being said, I'm not going to make an ed puzzle, even though I probably should, because I don't want you guys to have to deal with that drama. I would rather you guys pause when I ask you to pause and try your best, and then come back and see what the answer was and if you are on the right track. Okay, so with that being said, let's get going. 2.3, building a perfect square. Optima has a quilt shop where she sells many colorful quilt blocks for people who want to make their own quilts. She has quilt designs that are made so they can be sized to fit any bed. She bases her designs on quilt squares that can vary in size. So she calls the length of the side for the basic square x, and the area of the basic square is the function a of x equals x squared. That should look familiar to you guys. Okay, in this way, she can customize the design by making bigger or smaller squares. All right, so then it says if Optima adds 3 inches to the side of the square, what is the area of the square? So the first thing I want you to remember is that I've talked to you guys about this previously, that whenever we deal with area models, this is always what we're looking at. We're looking at an x by x square. Okay, that's the parent function. And the area of that is x squared. So this is what she started with. And then she said, hey, if she adds 3 inches to each side, what is the area of the square? Okay, so go ahead, and it says actually when Optima draws a picture, it looks like this. So go ahead and look at this picture right here and see if you can't figure out what the new area is going to be. Go ahead and pause the video. All right, hopefully you've paused the video and you've had a chance to try and figure it out. And this was the original block was x by x, and then we added 3, and we added 3, and now we need to figure out what the new area is going to be. Well, one of the areas should just be our side length squared. So one of the areas is x minus 3 squared, because that's the side length squared. Sorry, not x minus 3, x plus 3. X plus 3 squared. So that's one of the areas. The other area that they're looking for, actually that's all that they're really looking for. That's all they're really looking for is just that area, my bad. So they want you to look at the side length squared and figure out that this was the area and answer for number 1. All right, number 2 says use both the diagram and the equation that you just got to explain why the area of the quilt block is also a of x equals x squared plus 6x plus 9. So you can use whatever method you can, but go ahead and explain in a sentence or two why these two equations are equal to each other. It says use both the diagram and the equation. So how can you use the original equation you just got, this equation, to say that it equals this, but how could you also use the area model to show that? So take a couple seconds, pause the video, and see if you can't figure that out. All right, hopefully you've had a chance to pause the video and take a look. That would be ideal. But now let's go ahead and start looking at stuff and see what happens. So right away, the first method of figuring it out is you can say, hey, I know from the last assignment we had that I can take x plus 3 squared, and it turns into x plus 3 times x plus 3. These are the exact same thing. So if that's true, then I can also multiply all of this out and see what we get. So I get x squared plus 3x plus 3x plus 9, which simplifies to x squared plus 6x plus 9. So that proves algebraically that they're the same thing. But what part of the area model shows this? What part of the area model shows us x squared plus 6x plus 9? So let's go ahead and look at this area model once again. Okay, first of all, if you have an x by x, then you know that the area of the square is x squared. Okay? And now if this side length right here is x, then that means that this side is also x. Okay? And if we added 3 to every side, that means that each one of these lengths right here are 1. And these lengths or these lengths are 1. So basically each rectangle is a 1 by x, which makes the area of them x, because x times 1 is x. So every rectangle has an area of x. And then if this side length is 1 and this side length is 1, and that means that each block has an area of 1, each small little block. And I always call these C-squares, and you'll see why later. But anyway, so there it is. So I have 6 x's, there's 3, there's 6. I have 1x squared and 9 little blocks, which ends up giving me this equation. So there's the answer for number 2. Hopefully whenever you did this problem on your own, you got something kind of similar. All right, moving on to number 3 and 4 and all those. All right, here we go. The customer service representatives at Optima shop work with customers' orders and write up the orders based on the area of the fabric needed for the order. As you can see from problem number 2, there are 2 ways that the customer can call in and describe the area of the quilt block. Okay, so remember earlier we got 2 equations. One of them is in standard form, which is this one, and the other one is vertex form, which is this one. So we have a vertex form and a standard form. And go ahead and write this in your notes really quick, okay? Your vertex form, whenever you're looking at these blocks, vertex form, okay, that one's going to be base times height. All right, but specifically, it's going to be your side length squared. Okay, so that's what vertex form is. Standard form is the sum of all the shapes on the inside. So add all areas of shapes, right? So we just added the big block, the small blocks, and the rectangles, and that's how we got each form, right? So one way, this says one way describes the length of the sides of the block, and the other way describes the areas of each of the 4 sections of the block, and then you add them up. So that one's standard form. For each of the following quilt blocks, draw the diagram of the block, and then write 2 equivalent equations for the area of a block. Okay, so before I just give you the answers for this one, let's pretend that it said block with the side length. Let's say that it doesn't say x plus 2, but it says x plus 3. Okay, so that's what this would basically say, a block with a side length of x plus 3. Guess what? You're going to end up drawing the exact same shape that you saw in problem number 2 for this one. So you basically just say, hey, I start with this regular block, x by x, and then I add 3 rectangles to both sides. So there's 1, 2, 3, and then do it to this side. Okay, so you're going to do 1, 2, 3, and then basically you're going to figure out how many. There's only one number that can go here if you just connect all the lines, and now this is x plus 3. So this is an example. It says draw it and then give me both equations. So in this case, one equation is your side length squared, right? We'll just put y equals. And the other equation is x squared plus 1, 2, 3, 4, 5, 6 x's, and then plus 9. So this is the exact same problem as number 2, but for number 3 and 4, now you're going to make a side length of x plus 2 and a side length of x plus 1 and do the same thing. I expect on your assignment to see the area model and see both equations. That's for 3 and 4. Okay? All right. So number 5 is just asking, what patterns do you notice when you relate the diagram to the two expressions? Okay, so what patterns do you notice? There's some things that always happen. So see if you can find out something that's always happening. And if you need help, remind me next week or next class and we'll go over it. All right, here we go. Problem number 6. Problem number 6 says, Optima likes to have her little dog, Clementine, around the shop. One day the dog got a little hungry and started to chew up the orders. When Optima found the orders, one of them was so chewed up, there were only partial expressions for the area. Oops. Let's move this back. Okay, so help Optima by completing each of the following expressions for the area so they describe a perfect square. Then write the two equivalent equations for the area of the square. So let's go ahead and just look at 6a, and I'm going to go ahead and do that one for you. Okay, that way you know what's going on. So your equation is x squared plus 4x. You need to draw an area model that represents this. So how would we get x squared plus 4x? Remember, we're going to be making a square. So if x squared is here. But those x's, those are my rectangles. So if I want to make this, keep it a square, what do I need to do to make sure that I put all of these in the area diagram so it remains a square? Think about where you would put them. Would you put all of them on one side? How would you split them up is my question. Okay, how would you split them up? Well, the answer is if you want to keep being a square, then you're going to want to make sure you do the same amount on each side. So I put 2 on each side, and now I have x squared, and I have 4x's. Oop, that was a mistake. 4x's. All I have to do to finish it is find out how many little squares I have, which are right here. And the answer is 4. So that's what you're supposed to put on the end. And it's asking for you to write the two equivalent expressions. Well, here's one. Okay. The other one is just the side length squared. So what is the length of the side from here to here? Remember, this is x, and these are 1s, so it's x plus 2 and x plus 2, which gives us the equation x plus 2 squared. Okay? So for 6a, b, c, and d, you're going to do the exact same thing. Figure out what number goes on the end by drawing an area model and then determining what it is. Okay? Last but not least on this, we're going to try and figure out what the pattern is. So this is where it kind of gets a little bit tricky. Number 7. If x squared plus bx plus c is a perfect square, what is the relationship between b and c? In other words, how do you use b to find c, like in problem number 6? So basically, you're looking at these 4 problems over here. Okay, and you're going to say, hey, I had a b value of 4 and I got a c value of 4. And then you're going to do that for these other problems over here. I'm looking at these 4 problems, so A, B, C, and D. See if you can figure out the rule that if you know the b value, you automatically know the c value. So go ahead and pause, get a bunch of this done, and before I go over number 7, see if you can't figure out the pattern. All right, so I went ahead and just gave you the answers here, at least this portion of it, so you can see if you got these right. So go ahead and take a look. For the 6x, did you get 9, the 8x, 16, the 12x, 36, and we already got the top one. So if you didn't get that before, go ahead and get that, and now try number 7. Pause me before I give you the answer so you can see what it is. So number 7 says, what's the relationship between B and C? A lot of students don't figure out exactly what it is. It's actually pretty rare a student figures out the rule, and maybe they'll do it a little bit differently. But the rule is, if you know your b value, so you want to solve for your c value, you take your b value, you divide it by 2, or in other words, you cut it in half, and you square it. Okay? So to find, this is for a perfect square. For a square, a perfect square. This is called a perfect square because the sides of the area model are the same. Okay, and it gives us nice little c squared. That's why I call them c squares, so they represent the c value in standard form. Okay, so make sure you guys write this down. C equals b divided by 2 squared. Okay. And then it says, will this strategy work if b is negative? Why or why not? What I want you guys to do is test this out. Okay, test this out. If b is negative, let's try x squared minus 4x. Okay, what do you end up getting here? Well, c equals b divided by 2 squared. So in this case, b is negative 4. C equals negative 4 divided by 2 squared. Negative 4 divided by 2 is negative 2, and negative 2 squared, or negative 2 times negative 2, is 4. So yes, it does work, but you always get a positive number of c squares. If it's a perfect square, you're always going to have a positive number of c squares. See if you can do this for funsies. If I gave you the equation y equals x squared minus 6x, what's your answer going to be? I bet you can figure it out pretty quick. All right, lastly, will the strategy work if b is an odd number? And then what happens to c if b is an odd number? I'll let you guys fiddle with that. You could try negative 5 or positive 5. Don't even make it negative. X squared plus 5x. If you use the rule, what does this end up equaling? All right, guys, that's the end of the task. I hope everything worked out. I hope you guys learned some stuff. Let me know if you guys have any questions. Talk to you later.